Com check, channel 1.
You're loud and clear.
Roger, LC. Blue team is on station on level 12. Request that you give me a call, landline 5263 at your convenience.
Roger.
LC Flight, channel 1.
Go ahead, flight.
Firm ready for hold authority com check.
Proceed.
Okay, stand by for voice loop reconfiguration.
Roger.
LC, SMD on channel 1 for a com check. Cuddy here.
I have you loud and clear on channel 1.
I have you the same, LC, SMD out.
LC Flight, com check on air to ground 1.
I have you loud and clear on channel 1.
Copy, I have you loud and clear on CST, air to ground 1. This completes hold call authority com check.
Roger.
Minus 3 hours, 35 minutes. Oh, minus 3 hours, 30 minutes.
LC Slick on Channel 1.
Go ahead.
Hatch open ops complete. Confined space checks are nominal.
Roger.
Now minus 3 hours, 20 minutes.
LC Slick on Channel 1.
Go ahead.
Crew transport convoy is en route to LC-41. Estimated arrival to roadblock at L-306.
Roger. OSM, LC.
OSM, go ahead, sir.
Crew transport convoy is en route to pad. Permit entry into FHA.
Roger.
Now minus 3 hours, 17 minutes.
LCOSM.
Go ahead.
Yes, sir. For step 150, crew transport convoy is clearing roadblock. 18 personnel are entering FHA at this time.
Roger.
LC Slick on Channel 1.
Go ahead.
We're ready for pad support personnel to perform OSE radio comm checks and to proceed to ground level.
Roger. Proceed.
Copy.
Convoy has arrived at pad 8.
Roger.
LCOSM.
Go ahead.
Yes, sir. For step 160, crew transport vehicles entered pad.
Roger. Crew is clear to proceed to level 12.
Roger.
Crew transport vehicle has arrived at CAD.
Roger.
Crew is entering CAD elevator.
Roger.
Crew has arrived on level 12.
Roger.
LC Slick on launch ops. Or sorry, on channel 1.
Go ahead, Flick.
Yeah, crew has arrived at cat level 12, and RCTV is standing by for OSM direction to return to the fallback area.
Roger. And OSM, LC?
OSM.
Roger, we can give go ahead for the CTV to clear the pad.
Roger that.
LC Locks 2.
Go ahead.
Request permission to perform Centaur LO2 transfer line refill.
Roger. Proceed. Blue team lead, LC.
LC OSM.
Go ahead.
Yes, sir. For step 160, 16 personnel have exited the FHA roadblock.
Roger. Go ahead. And Blue Team Lead LC?
Go ahead, sir.
Yeah, just be advised we're going to perform a LOX refill at this time.
Roger that. I'll alert the crew.
Roger. And LOX 2, you have a go to proceed.
Roger.
minus 2 hours, 45 minutes.
Tech 5.
Go Tech 5.
NPRV unlocked, extended, and caps are pushed in.
Pad copies all.
O2 monitors coming out. Pad.
Copy. 2 O2 monitors being removed from the vehicle.
All right, Starliner crew. It's been an honor not to stop in my group of my friends. Anything else you need help with before we leave?
LC Fuel 2.
Go ahead.
Just wanted to make you aware that my topping valve I to P has failed and dropped to 0.
Roger. AC, LC.
AC on 1.
Roger. Fuel 2's reported a I to P has given an anomaly. Please screen the anomaly team and provide a recommendation.
We'll go.
Tech 5.
Hey, Cruise
LC
can
Lock
work
2.
some audio system checks.
Go ahead.
I've just experienced a similar anomaly with my LOC 669
Copy, inward.
IDP as well.
And I'm going to
Valve
flip you back
locks,
over to ground op.
also commanded and is
Copy.
0.
Okay, so you're in a stop flow effectively?
That's a firm, not flagged, but the valves are all closed in the skid,
Valves
so we're
are
not closed in
closed.
the vehicle.
Copy that. Yeah, AC also for locks 2.
Copy that.
Starliner Houston for the entire crew, comm check on air to ground 1.
CDR, loud and clear, air to ground 1. TLT, loud and clear, air to ground 1.
Starliner Houston has both crew members loud and clear, air to ground 1. Stand by for a comm check of air to ground 2 via the T0 line. You're going to hear me and reply on air to ground 2. Stand by.
Houston, CDR, loud and clear, air to ground 2. And Houston, TLT, loud and clear, air to ground 2. Standing by.
Starliner Houston on air to ground 1. Audio system checks complete. In 10 seconds, it will be L minus 2 hours, 18 minutes. 3, 2, 1, mark. L minus 2, 18.
Good check.
Copy, good check.
LC Slick on
CDR,
channel 1.
comm panel, list
Go ahead,
off
Slick.
on air to ground 1 and 2.
Crew insertion is
On
complete.
air to ground
Roger.
And Starliner, we'd suggest listen only on air to ground 2, just makes it a bit easier for us.
That's what I figured. Okay, there's air to ground 1 only talk.
Okay, copy.
So
You're
field 2,
sounding real good and clear here, so it's all working.
Go ahead.
Roger, at this time, go ahead and command a stop flow. And lock.
We understand that you two had something to do with that.
Roger,
so
you also
on behalf of
command a
NBC,
stop flow
thanks.
at this point.
Okay.
Field 2 is complete.
Hey, it's our pleasure. A well-fed team is a well-ready team, so we are happy you guys are well-fed.
Slick and flight LC channel 1.
Flight here.
Yeah, just for your awareness, we're troubleshooting a control issue on both the Centaur LOX and hydrogen topping valves. So we're currently have both those tanks in a stop flow condition, so we're not actually topping at this point. No safety concern at this point, but just want you to know we're troubleshooting that.
Roger.
Flight copies following on channel 6.
Roger.
L minus 2 hours, 10 minutes.
ECS LC.
Go ahead.
Adjust CI flow rate to 170 pounds per minute.
Roger.
LC on 1, this is RLM.
Go ahead, RLM.
Yes, sir. I have received, appears 4 OTCs at this time. The first one is line item 326, and LH2 Delta P. Looks like they all 4 are.
Roger.
Data's out of tolerance.
Roger. Understand, and that's a result of us not topping at this point. Are all 4 of those OTCs Delta P related?
Yes, sir, they are.
Yes. Okay, let's continue to monitor that while we're troubleshooting the topping valve situation.
I copy.
Roger.
LC Slick on channel 1.
Go ahead, Flick.
Yeah, no, I gave you crew insertion is complete, so the team did exit the vehicle, put the last couple bags in, and they're starting hatch closure preps, and we'll stand by for approval to close hatch.
Roger.
Starliner, Houston on 1.
Go on 1.
Just giving you an update. ULA is working an issue with a Centaur topping valve. No safety concerns we're monitoring, and we'll let you know where it goes, but that's the reason for the delay on hatch closure. We'll keep you abreast.
All right, thanks for the heads up.
LC on one. This is RLM.
Go ahead.
The corresponding 4 locks parameters have now been received as alarms as well.
Roger. Thank you. ECS LC.
Go ahead.
Adjust CISA temperature to 145 degrees Fahrenheit.
Roger.
L minus 1 hour, 55 minutes.
LCM1AC.
Go ahead.
Okay, we have a recovery plan to coordinate with you. We are testing this out still as we speak, waiting for that to complete. Once we have that thumbs up from still, what we're planning to do is to disable her safety. We need to run option 354 to disable the fluid monitor testing. Then we need to switch from VRIC 3 to VRIC 1. That'll be an SYS function. Once that's complete, we can go ahead and reestablish fluid monitor and a her safing capability, and that should put us into a position to proceed.
Roger. And do we have an estimate when the still test be complete?
I was told 5 minutes ago, about 5 minutes, so it should be imminent.
Roger. And LC concurs with this. LD?
LD concurs.
Roger. And AC, could we get an update on the still test?
I'll get that right now.
And SYS LC?
Go.
Roger. Do you have the steps as were outlined for executing this?
That's affirmative.
Switch? Okay. Okay, let's see, flight, channel 1?
Flight here.
Yeah, Roger, I understand we kind of want to give the broader team a little insight to what we're planning to do here, so if we want to merge the net, we could do that at this time.
In work.
NLC, the pad team is on channel 1. We'll be listening in.
Roger, thank you.
LC flight and Starliner flight will merge channel 1 and air to ground 1. So LC gives the crew and the pad team an update.
Roger, and Starliner, can you copy me?
That's loud and clear, LC.
Roger. So at this time, what we have is a control issue going to the LOX and hydrogen topping valve. So they are both closed this time, so we're not topping Centaur at this time. So we've put in a troubleshooting plan together, and we're going to switch the control logic from VRIC 3 to VRIC 1, because we have redundancy in our control system. And so we're going to switch to VRIC 1 and hopefully restore this topping control and get the vehicle back into topping mode.
Great. Copy off. Standing by.
Roger.
Copies as well.
Blue team lead copies.
Roger. And flight, let's go ahead and leave this, if you can, leave this merge until we're done. Should take about 5 minutes to complete this operation.
LC copy, lead your merge.
Roger.
minus 1 hour, 45 minutes.
And flight and Starliner LC on channel 1.
Flight here.
Starliner, go ahead.
Yeah, Roger. So right now we are exercising the steps to do the transfer from VREC 3 to VREC 1. We're executing that in our still test in the still lab just to make sure that we have the proper procedure steps before we execute it here on the pad. So team's asking for a few more minutes to complete that test.
Starliner, copy, standing by.
Flight copy.
LCS on 1.
Go ahead, SYS.
Step 200, L2 balloon cycle task is complete.
Roger. Roger.
minus 1 hour, 40 minutes. Oh my, 1 hour, 30 minutes. Oh my, 1 hour, 35 minutes.
LCM1.
Go ahead.
AC. I'm ready to provide the steps to switch the hard on the BREC.
Roger. LD. Gentlemen.
LD1.
Proceed, AC.
Okay, we did run through this through the sill. Slight modification from what I described earlier. First SOS option 547 to disable her safety. Option 548 to switch BREC 3 to 1, both the analog and ECM. Then there's a command lines that the SOS has that will be utilized during the switch. Finally, re-enabling the safety using option 547. Like that at that time.
Roger. And understand and concur. LD. Roger. SYS, LC.
Yeah.
Roger. Are you ready to implement this time?
Affirmative.
Roger. Proceed.
In work. We'll report when complete.
Roger. And Fuel 2 and LOX 1, LC.
LOX 1. Fuel 2.
Roger. So during this transfer, you may pick up Flume number 29 and 31 due to a miscompare, but there's no issue with that, and we'll just clear that after the switch is complete.
Copy. Roger. LC, LOX 1.
Go ahead.
For awareness, I did trip from 131 and went into a soft drain.
Roger.
LC.
Go ahead.
Same for me. I also went to soft flow drain and tripped Flume 129.
Copy. Just waiting for SOS to report complete, and then we'll go ahead and recover from that.
Copy.
LCSYS on 1.
Go ahead.
Complete.
Roger. So LOX 1 and Fuel 2, go ahead and reestablish topping at this time.
Roger.
And LOX 2, LC. Go ahead. Roger, you can reestablish topping also.
Roger.
LCR11.
Go ahead.
I just received OTC for second stage GSUT model map, line 9960. Date went on tolerance.
Okay, copy.
LCP unit 2.
Go ahead.
I'm seeing our Centaur helium bottles are bent.
Can you hit a stop flow on that? Or do you understand why they're venting?
Looks like I've got a valve failed to verify.
And IFS LC channel 1.
Press on 1.
Right, is there an action we can take to stop venting?
Occur with a stop flow.
Roger. P&E 2, did you copy stop flow?
I copy inward. LCS complete and it did stop.
Roger. ACLC channel 1.
ACLC.
Roger. During the transfer appears that we did pick up Centaur helium bottle venting command, which looks like, I don't know, we vented about 1,000 PSI. If you would please convene the anomaly team and provide a recommendation.
We'll go.
LC Loxy. LC Loxy, channel 1.
Go ahead, Loxy.
At this time, it's not to resume topping, but I will need to transfer.
Roger. Proceed. And SYSLC. Roger, just as a result of the switch there to VRIC 1, you're seeing all normal operation at this time?
That's affirmative.
Roger. And LOX 1, advise when you're reestablished stopping.
Roger, we're still in Rachel right now. It should be any minute now.
Roger.
And I'll see where we're reestablished topic now.
Roger.
LC on 1.
Go ahead.
Yes, understood. Got Easter locks percent full alarm. Out of tolerance.
Roger. And we've reestablished topping, so we should get that restored here shortly. Thank you. PNE2, LC.
Go ahead.
Start center and chill down.
Roger.
LC Slick on channel 1.
Go ahead.
Looking for approval to go ahead and move the hatch frame and continue with hatch closure preps.
Roger, proceed.
Copy.
LC on 1AC.
Go ahead.
I'm ready for provide a recommendation for the Centaur bottle repress.
Roger, LD, channel 1.
LD on 1.
Proceed, AC.
Okay, so we need to have PNE2 use option 350 to reset the stop flow, and then option 320 to deselect resume. That will get us back in configuration to recharge the ball.
Roger. Understand, concur. LD
concurs.
And PNE2, LC.
Go ahead.
Roger, you ready to execute that this time?
Can you please repeat the steps I was initiating CEC?
Roger. That's option 350 to reset the stop flow, and then 320 to deselect and resume.
Copy. I'm prepared.
Roger.
Roger.
And fuel 2, LC.
Go ahead.
Roger. Have you been able to restart topping at this time?
Affirmative. And topping.
Roger. And everything's nominal?
Affirmative.
At some point, could you give me an estimate when you think you'd be back at flight level?
Affirmative. I will get back to you.
Thank you. And lock 2, LC.
Go ahead.
Roger. Have you initiated topping yet?
That's for regional was successful. Currently at 98.9.
Roger. So flight and Slick and Starliner, channel 1.
Flight, sir.
Starliner, go ahead.
Roger. So at this time, we've completed the transfer from VREG 3 to VREG 1, and all our systems are back active topping and returning Centaur helium to flight pressure. So at this time, I think we're on track to continuing to count down, and flight, I think we can demerge nets for the time being.
Good news, LC. Nice work.
Roger. Thanks, Starliner.
Good news, flight copies will deconfigure.
LC, fuel 2.
Go ahead.
Should be approximately 20 minutes.
Roger.
And LC Slick on channel 1.
Go ahead.
Wondering if you had an estimated for hatch closure weather brief.
Yeah, getting ready to issue that right now.
Roger.
RC, LC.
RC on 1.
Conduct weather briefing on channel 8 weather conference net.
Roger.
LC locks 2.
Go ahead.
Centaur LO2 at flight level.
Roger.
LC PNE2.
Go ahead.
Bottles have returned to flight mass and flight pressure.
Roger. And arm control, LC.
Arm control.
Power on crew access arm hydraulic heater as required.
Roger. LC PNE 2.
Stand by 1 PNE 2.
Standing by.
Go ahead, PNE2.
I just want to give you step 220, Centaur engine chill down initiated.
Roger. In Slick LC, channel 1.
LC, this is Slick on channel 1.
Roger, Slick. You have a go to proceed with hatch closure.
Roger.
Starliner, pad, air to ground 1.
Go ahead, Pat. Starliner.
Starliner, be advised we've been given a go to proceed with final hatch closure.
Outstanding. Nice job, guys. We'll see you in a couple of weeks.
Much appreciated. See you when you
or longer.
And LOX 1, LC.
LOX 1.
Maybe I just didn't get it formally from you, but you're back at flight level.
Affirmative.
Roger.
Minus 1 hour, 10 minutes.
RC, LC, channel 1.
RC, go.
Verify range ready for FTS open loop test.
Verified.
FTS, LC.
This is FTS.
Start final open loop FTS test.
Roger.
LC Slick on channel 1.
Go ahead.
Hatch closure is complete, and we're moving into hatch gross leak checks.
Roger.
Starliner Houston on 1.
Houston Starliner, go ahead.
Starliner Houston back with you, ready for pre-launch cabin leak check. You can prepare for cabin pressurization per your checklist. Configure the HIU Vox sensitivity knobs to maximum.
Good work. Cabin vent valve cap is removed.
We copy. Cabin vent valve cap removes. And Starliner Houston, the ground team's going to perform cabin pressurization at this time. You can expect a caution for cabin P high and for cabin PPO2 high due to the higher cabin pressure. Acknowledge the alarms.
Starliner copies, Wilco.
L minus 1 hour, 1 minute.
Starliner, short delay there, but we are
LC, fuel
proceeding
2.
with cabin pressurization now.
Centaur LH2 is at flight level.
Roger.
We're ready.
LC, this is FTS on Channel 1.
Go FTS.
Operation 55, Step 270, FTS open loop test is complete.
Roger.
Starliner, it's Houston on 1. Good pressure. The side hatch is being configured now. Audible noises may be heard.
Standing by, thanks.
L minus 50 minutes.
LC Slick on channel 1.
Go ahead.
Hey, cabin pressurization is complete. They are in the leak check. We're finishing up hatch access panel work and clearing the white room, so we expect to be clearing out here in a couple minutes.
Roger.
LC, this is Blue Team Lead on 1.
Go ahead.
Request permission to begin white room closeout.
Roger. Roger, thanks, Slick. Blue team, perform toxic vapor and O2 checks when raising the environmental seal and configure white room for launch.
Roger.
And Slick, if you get a annulus purge disconnect time.
Yeah, and LC, this is Slick. We're calling it 1537 Zulu.
Roger.
Starliner Houston, cabin leak check complete. You can open the vent valve.
All right, great. That's in work. I guess you're watching the numbers, Houston. Cabin vent valve is open.
Copy, vent valve open, and we are watching. Thanks. Starliner Houston, that's a good vent and a good leak check. You can close and cap the vent valve per your checklist, configure the HIU box sensitivity knobs back to desired.
Hey, Starliner copies didn't work. Houston Starliner cabin vent valve closed and capped.
Houston copies, close and cap. Good config. A couple minutes ahead of schedule, but if you want, you can grab your checklist, and we'll go through the final AE checklist updates now.
Okay, we're ready.
All right, Starliner, first for comm checks, they're complete. We have each other loud and clear. Moving on to the updates. I think it's all no change, but for the record,
LC, this is Blue Team Lead.
Go ahead.
Environmental field has been raised and white room is configured for launch. Blue Team is ready to clear the path.
Roger. Clear the blue team to the FHA roadblock.
Roger.
14
OSM, LC.
54
OSM.
14
Clear the flight hazard area. Turn area warning system lights for complex 41 to flashing red, and sound the area warning horn.
Triage.
Actually, hold on the area warning horn, please.
I'll copy.
Roger. Holding on the horn.
Okay, MECO 4:29. MECO
FELC.
11:54.
Go ahead.
Disable CAT TVM system monitoring.
Roger. We copy 28 seconds, excess burn duration, and we'll go north to triage 6 if necessary.
LCFE.
Go ahead.
And those are all good words, Starliner. Good readback. One additional item for you. In the commander's folio, you'll recall you have your two tablets. You've got a serial number 12 and a serial number 13. They're both ready to go, but one thing for you. Serial number 12, we were looking at footage here. Its time is out of sync, so it's no issue for you till orbit. When you're on orbit, you'll want to get that tablet, serial number 12, back in sync with the time on your DUs. It's only going to influence where you see the red line and bold. So if you did have to use bold before that, go ahead and do it on 13. Otherwise, we'll just resync in flight, and we can help you with that when we get there.
All right, good words. We'll copy that, and if we have any questions when we get there, we'll give you a call. And I have confirmed that I can reach the tablet.
Houston copies.
LC Flight Channel 1.
Go ahead, flight.
Ready for comm check the crew on CC Underground 2.
Roger.
L minus 35 minutes.
LC Starliner, loud and clear.
Starliner Houston, we followed all that. That completes the comm checks. Good comm checks all around.
contact all around. Thanks.
LC, this flight control.
Stand by, flight.
Blue team has cleared the path.
LC OSM.
Go ahead, OSM.
Yes, sir. Would you like me to go ahead and sound the horn at this time?
Yes, please.
Roger.
And flight control, go ahead.
Yeah, I was going to give you step 70 for adjust if you're ready.
Okay, proceed.
L-3 primary steering file adjust underscore AV085 underscore 06 with SDL CRC 2912 has been received, verified, and is ready to load into the Inca.
Proceed with load.
Roger.
Roger, SE.
LCOSM.
Go ahead.
Yes, sir. Per step 20, operation 60, blast engine area is clear.
Roger.
Minus 30 minutes.
RC, conduct weather briefing on Channel 8 Weather Conference Net.
Roger.
Arm control, start arm hydraulic final prep.
Roger.
LOX 1, perform pogo suppressor charge.
Roger.
Prop 1, perform RD180 transducer converter calibration.
Roger.
P&E 2, perform Centaur LH2 SVV cycle test.
Roger.
LC Prop 1.
Go ahead.
RD-180 transducer calibration is complete, and the engine FIB is in the closed condition.
Roger.
L minus 29 minutes.
Flight control, start flight control, final prep.
Roger.
LC, PNE2.
Go ahead.
Since our LH2 SVB cycle tests are complete.
Roger. And flight control, LC.
Go ahead.
Roger. Do we have the temperature update complete?
Roger. The RP1 temperature update complete.
Roger. Prop 1, initiate fuel fill sequence.
Roger.
LC on 1A.
Go ahead.
Yeah, we've been discussing it for the CISA temp. It's a noisy measurement. I'd like to take this to 6, get a recommendation, probably to disable.
Roger. Convene the anomaly team and provide a recommendation.
We'll go.
L minus 27 minutes.
LC arm control.
Go ahead.
Step 100. Arm hydraulic final preps are complete.
Roger.
L minus 25 minutes.
LC OSM.
Go ahead.
Yes, sir. Per step 60, flight hazard area has been cleared. All personnel accounted for.
Roger.
LC on 1AC.
Go ahead.
Yes, we've discussed the CISA temp, and we have a recommendation for you.
LD, gentlemen.
LD.
Proceed, AC.
Okay, this measurement is noisy, but all of our actual components are reading as expected. We are recommending disabling line item 390.
Roger, LC concurs. LD?
LD concurs.
Roger. RLM, LC?
RLM on 1.
Roger, please disable line item 390.
Active.
LC, this is flight control.
Go ahead.
Step 90, flight control final preps complete and Atlas hydraulics at standby pressure.
Roger.
LC RLM on 1.
Go ahead.
Line item 390 has been disabled.
Roger.
LC, this is flight control.
Go ahead.
Step 110, L-3 primary steering file adjust underscore AV 085 underscore 06 with SDL CRC 2912 has been verified and loaded into the Inca.
Roger.
Oh, minus 23 minutes.
SYSLC?
Yep.
Switch all secondary decoms to RF link and verify lock.
Roger.
Also initiate orbital parameter calculations on primary CCLS.
Roger.
Oh, minus 22 minutes.
LC, LOX 1.
Go ahead.
Pogo suppressor charge is complete.
Roger.
Oh, minus 21 minutes.
LCSYS.
Go ahead.
Step 90, all secondary decoms verified on RF link.
Roger.
Oh, minus 20 minutes.
Starliner, there's
Beanie 1, reinitiate AHV charging.
Configure suit flow.
RLM, verify redline monitor and event table are in the correct configuration for terminal count.
Verified.
Good work.
RC, verify solar radiation acceptable for launch.
Verified.
Houston, Starliner, visor config complete.
Houston copies, visor, config complete.
All communications switch to channel 1. All personnel and visitors remain in present position until launch. Maintain operational silence in the LCC.
This is the LC with a terminal count briefing. If a condition exceeds the launch constraint anytime after the terminal count status check, the observer shall announce hold, hold, hold on channel 1, identify their station, and briefly state the reason for the hold.
LC prop 1.
Go ahead.
Fuel fill sequence is complete. Start bottle fill is nominal.
Roger.
L minus 18 minutes.
Flight control, perform launch on time verification.
Roger.
L minus 17 minutes.
OSM, place SRB ignition SNA switch to the enable position.
SRB ignition enabled.
And verify FCO, RCO, and OSM hold fire switches are in the proceed position.
Ready to proceed.
Launch on time verified.
Roger.
LC Peony 1.
Go ahead.
AHB charging reestablished and at flight mass.
Roger.
L minus 16 minutes.
Roger.
Starliner, we see your CM Essential. That's just to do with the internal power transition. No action.
Okay, no action. We got the soup fan DP low. It's back on now.
Looking.
LC flight, channel 1 and air to ground 1 are now merged into air to ground 1.
Roger.
Roger. LC flight, air to ground 1, ready for com check with Starliner and channel 1.
Roger. Roger. Starliner, LC, com check on channel 1.
So LC, we got you loud and clear. Looks like we got suit fan, all suit fans failed a warning.
And I copied your comm check, Starliner. And Capcom, did you catch that message?
And Starliner and LC Capcom A-firm, we see the messages. We're working. More to follow. Stand by.
Standing by.
Starliner, visors open, please, while we work the suit fans. Visors open.
All right, visors are open. I'm sure you saw it, Houston, but suit fan Bravo went down and switched to Alpha. It had a BP low, and then it, of course, went off. We still show power to Alpha is on.
Houston copies.
minus 13 minutes.
And Starliner, we showed the same for your info. We're swapping suit fans back to Bravo. Continue to stand by for us.
Standing by.
Minus 12 minutes.
LC Flight Channel 1.
Go ahead.
Yeah, the condition we're in an LCT condition with both suit fans down. We're trying to get these reactivated, but we're going to proceed.
Roger. So good to stow the crew access arm.
I'm good.
Roger.
Minus 11 minutes.
Arm control, stow the crew access arm for launch.
Roger.
Starliner, on our end, we brought suit fan Bravo back on. It looked good. We need both. We need to prove that A is also there, so we're commanding Alpha on and then off at this time. More to follow.
Yep, we see it. And we're still visors up, so you know.
All right.
Minus 2 minutes.
Flight, verify CST 100 on internal power.
Verified.
Starliner, configure ordnance for launch.
That's in work.
LC Flight Channel 1.
Go ahead.
Yeah, we reactivated suit fan Bravo. Suit fan Alpha is also working to a clear LCC condition. And for the crew, you can take visors down.
Visors down and ordnance configured.
LC copies both.
LC arm control.
Go ahead.
Crew access arms stowed for launch.
Roger. LC switch to ready position. All steps are complete prior to status check.
L minus 7 minutes.
Status check to proceed with terminal count, Atlas systems, propulsion,
Go.
hydraulics,
Go.
pneumatics,
Go.
LO2,
Go.
water,
Go.
Centaur systems, propulsion,
Go.
pneumatics,
Go.
LO2,
Go.
LH2,
Go.
has gas,
Go.
electrical systems, airborne,
Go.
ground,
Go.
facility,
Go.
RFFTS,
Go.
flight control,
Go.
GCQ,
Go.
op support,
Go.
comm,
Go.
umbilicals,
Go.
arm control,
Go.
ECS,
Go.
redline monitor,
Go.
quality,
Go.
op safety manager,
Go.
ULA safety officer,
Go.
vehicle system engineer,
Go.
anomaly chief,
Go.
range coordinator,
Clear to proceed.
flight director,
Houston flight is go.
Starliner,
Starliner, go.
launch director,
You have permission to launch.
proceeding with the count. ALC, verify T0 is set for 16:25:40 Zulu.
Verified.
Starliner, net is clear.
Thank you, LC. For all of you sitting on console, whether you're in Houston, BMCC, ASOC, Atlas, this is a great day to be proud of your nation. And all of you listening as well, whether you're at Banana Creek or the Causeway or the rooftop of LCC or the ASOC, and other places around our nation, like the Bay Area building and other places where you are viewing what's taking place. Again, for you, it's a great day to be proud of your nation, great day to be proud of Boeing, great day to be proud of UOA and NASA. And we are one nation, under God, indivisible. And we together use the power of that combination, we can do some pretty amazing things. So LC, with that, we are ready to put some fire in this rocket and propel this spacecraft to the International Space Station, where all these fine Americans have designed and have prepared it to be. Calypso, take us to space and back.
Roger, Starliner.
LC flight, Starliner configured for terminal count.
Roger. All steps are complete prior to terminal count.
On my mark, the time will be T minus 4 minutes and counting. 3, 2, 1, mark. .355.
Ground pyros enabled. Hold. Flight control proceed to CCLS, hold it. Approximately T minus 350.
LC switch not ready. All personnel turn to recycle section. Operation 80. LC switch is not ready. Clock stopped at T minus 3 minutes 50 seconds. Starliner, you should not hear any vent at this point.
Starliner standing by.
ALC reset countdown clock to T minus 4 minutes and holding.
Active.
LC Peony 2.
Go ahead.
Centaur tank pressures are stable.
Roger.
LC Peony 1.
Go ahead.
Atlas tank pressures are stable.
Roger. OSM, place SRB ignition SNA switch to disabled position.
SRB ignition disabled.
Okay, consoles, step 60, report launch vehicle status. Atlas lead.
Atlas tank pressures and helium bottles stable. Atlas propulsion system stable.
Roger. Centaur lead.
Centaur tank pressures and helium bottles stable. Centaur propulsion system stable. Has gas readings nominal.
Roger. Vehicle electrical. VE, channel 1.
Avionics system stable.
Roger. And LC can verify no indications of hazards. Flight, LC.
LC Starliner systems are stable.
Roger. Starliner, last arm switch to off.
Last arm switch is off.
SCS in pre-flight mode, SSVAPs inactive, OCU safe, and EDS in test mode.
Roger. Arm control, deploy the crew access arm.
Roger.
Starliner, proceed with ordnance deactivation.
Action 1. Ordnance deconfigured. All off.
Roger.
LC.
And go ahead, ALC.
Countdown clocks reset, T-minus 4 minutes and holding.
Roger. Flight, verify CST 100 ordnance is safe.
Verified.
Okay, all stations, recycle systems back to T-minus 4 and holding configuration. Hold time occurred at T-minus 3 minutes 50 seconds. Report status at completion. And flight, LC.
LC.
CST 100 power to external.
Copy. We'll put it in work.
LC Loxon.
Go ahead.
Subset Bravo, Atlas LO2 continuing topping.
Roger.
LC Lux 2.
Go ahead.
Substep Golf, Centaur LO2 continuing topping.
Roger.
LC Field 2.
Go ahead.
Centaur LH2 continuing topping.
Roger.
LC Peony 1.
Go ahead, Peony 1.
Atlas pneumatics, pressure stable.
Roger.
LC Peony 2.
Go ahead.
Substep Echo CEC active.
Roger.
And substep Foxtrot sensor pneumatic system stable.
Roger.
LC Prop 1.
Go ahead.
Substep Charlie and substep Delta, Atlas propulsion and hydraulic system stable.
Roger.
LC ECS.
Go ahead.
Substep November ECS set point stable.
Roger.
LC, this flight control.
Go ahead.
Substep Kilo, flight control ready.
Roger.
LC arm control.
Go ahead.
Crew access arm is deployed.
Roger.
First step 310, substep Oscar. Crew access arm is deployed and latched.
Roger.
LC, this is RLM11.
Go ahead.
Step 310, substep Mike. Red line monitor is ready.
Roger.
LC has gas.
Go ask gas.
Substep Hotel has gas. Normal scan pattern including cat.
Roger.
And flight LC. Channel 1.
Flight. Yes.
Roger. Secure CST-100 prop system. Last valve to remain open.
Right, flight copies. Probably take us at least 5 minutes here.
Yeah, copy. FTS LC.
FTS?
Yeah, just looking for your recycle status.
Recycle.
Roger. SYS LC.
Yes, LC, GC3 is ready.
Roger. Launch Director, LC Channel 1.
LDM1.
Yes, sir. So we had a hold call at T-minus 3 minutes and 50 seconds by the CCLS launch sequencer. So at this time, we've completed our recycle back to T-minus 4 and holding configuration and ready to proceed with a scrub crew egress operation.
Yeah, roger that. Stand by.
Roger.
You have a go to proceed, LC.
Roger. Okay, all personnel going to Operation 85. OSM, LC.
OSM.
Establish the BDA roadblocks and open the flight hazard area.
Roger.
And all personnel on Channel 1 will be starting an approximate 65-minute hold at this time for flight crew egress. All systems maintain T-4 and holding configuration. Arm control, LC.
Arm control.
Yeah, per step 40, can you give me that call out on the status of the crew access arm?
Crew access arm deployed and latched. Arm control is terminated, ready for personnel access.
Roger. And FE, LC.
Go ahead.
Start CAT TVM system monitoring.
Roger.
RLM, LC.
RLM on 1.
Disable RLM line items for crew egress per red line report.
Roger.
LCFE.
Go ahead.
CAT TVM system enabled. Readings nominal.
Roger.
LC flight, channel 1?
Go ahead, flight.
Yeah, CST 100's on ground power.
Roger. And flight, LC.
LC, go ahead.
Yeah, just looking for your estimate for prop system securing, to support pad entry.
Need 5 more minutes.
Roger. Thank you.
LC RLM on 1.
Go ahead.
RLM line items disabled for red line report.
Roger. PNE2, LC.
Go ahead.
Secure CEC and activate safing purge.
Roger.
FTS, LC.
This FTS?
Secure RF, FTS, and GPS metric tracking.
Roger.
LC PNE2.
Go ahead, PNE2.
CEC secured and safing purge activated.
Roger.
Starliner, no action for you in the cabin temp high as long as it's still okay in there.
Yeah, we're fine. No action.
LC flight channel 1.
Go ahead.
Prop system is secure.
Roger. This is the LC on 1 with a readiness poll for pad entry. Atlas Systems, propulsion.
System stable.
Pneumatics.
Tank pressure stable, bottles at flight pressure.
LO2.
Topping at flight level.
Water.
System stable.
Sensor systems, propulsion.
System stable.
Pneumatics.
Tank pressure stable, bottles at flight pressure.
LO2.
Stopping at flight level.
LH2.
Topping at flight level.
Has gas.
Nominal background level.
Electrical systems, airborne.
Ready.
Ground.
Ready.
Facility.
Ready.
RFFTS.
Ready.
Flight control.
Ready.
GCQ.
Ready.
Op support.
Ready.
Com.
Ready.
Umbilicals.
Ready.
Arm control.
Deployed and latched.
ECS.
System stable on GN2.
Quality. Op safety manager.
Ready.
ULA safety officer.
Ready.
Spacecraft coordinator.
Ready.
Anomaly chief.
Ready.
Range and weather.
Ready.
Flight director.
Flight director is ready.
Starliner.
Starliner's ready.
Launch director.
Ready.
Proceeding with pad entry. OSM, turn area warning system lights for Complex 41 to flash in amber. Establish CAT access beacon and normal access. Maintain roadblock control and permit blue team to enter the FHA.
Roger.
Starliner, it's Houston again. We are ready for you to prepare to egress, so you have a go. Open visors, you can unstrap, and CDR perform. Crew prepared to egress per your checklist. Report complete. That'll include the vent valve cap.
All right, that's all in work. Here we go. Open in the vent valve.
Okay, from
Arm control, verify inhibit remove for CAT emergency egress water system.
Verified.
Spacecraft coordinator, begin video surveillance of blue team pad activities.
Roger.
Locks 2, notify LC prior to performing center locks transfer line rechill.
Roger.
Houston, cabin vent valve is open. Prep for egress complete.
Copy all.
Arm control, LC.
Arm control.
Verify CAT environment acceptable for personnel entry.
Verified.
Has gas, LC.
Go ahead.
Verify CAT and launch vehicle has gas readings are acceptable for personnel entry.
Verified.
And flight, LC.
Flight's here.
Verify CST 100 prop system is stable and acceptable for personnel entry.
Verified.
Roger.
LCOSM.
Go ahead.
Yes, sir. 8 personnel entering BDA at this time.
Roger.
Blue team is entering the pad.
Roger.
Blue team is parked at the base of the cat.
Roger. This is the LC on 1. The blue team has arrived at the base of the cat and is proceeding to cat level 12.
Starliner copy.
Blue team arrived on level 12.
Roger.
Check channel 1.
Auto clear channel 1.
Yes, sir, this is Blue Team Lead. We've arrived at the White Room. Toxic vapor and O2 checks are nominal. Proceeding with White Room configuration for crew extraction.
Roger.
LC, this is Blue Team Lead.
Go ahead.
Yes, sir. The white room is configured for Starliner access. The Boeing Blue Team can proceed.
Roger. Copy. Slick LC. Channel 1.
Slick.
Proceed with CST 100 hatch operations and crew egress.
Roger. Put in work.
And flight LC Channel 1.
LC, go ahead.
Remove air to ground 1 from Channel 1.
Right, in work.
LC, Slick on Channel 1.
Go ahead.
So hatch is open. We're going to have the crew go ahead and kind of self-egress so we don't have to put all the floors back in before they get out. So requesting the CTV and convoy to return to the pad gate.
Roger. Put that in work. OSM, LC.
OSM.
Notify crew transport convoy to return to pad. Permit entry into BDA.
Roger.
And slow.
Go ahead.
LC OSM.
Go ahead.
Yes, sir. Crew transport convoys cleared the roadblock. 16 personnel entering BDA at this time.
Roger.
LC OSM.
Go ahead.
Yes, sir. Per step 140, crew transport convoy standing by at pad gate.
Roger. And slick LC.
Slick.
Yes, so we got the convoy at the pad gate just waiting for you to tell us when we're ready to pull up to the cat.
Yep, we're just doing the last bit of inventory of Sonny's bag, and then we'll get them to do audio checks and we can call in the CTV.
Roger.
And LC Slick on channel 1.
Go ahead.
Ready for CTV to come and to do a comm check on OSE.
Roger. OSM LC.
OSM.
Crew transport vehicle is clear to proceed to cat.
Roger.
CTV has departed the pad.
LCOSM.
Go ahead.
Yes, sir. For step 150, crew transport vehicles cleared pad and convoys en route to ONC.
Roger.
LC, this is Blue Team Lead on 1.
Go ahead, Blue Team Lead.
Yes, sir. Looking ahead at step 160, I wanted to verify that we are indeed leaving the environmental seal intact for this 24-hour scrub turnaround, and we will raise the floor to the pre-cryogenic levels.
Yeah, so we are leaving the crew access arm extended. So I think we want to leave it in the same configuration we did when we scrubbed back on the 6th.
Yes, sir. So the procedure in step 160 has us raising the seal, but that is not going to be what we want to do.
Yeah, that's a carryover from our previous configuration. Okay, I'm with you. Copy that and concur.
Understood, sir.
LCOSM.
Go ahead.
Yes, sir. 18 people have exited FHA roadblock.
Roger.
LC, this is Blue Team Lead.
Go ahead.
Yes, sir. Once we are complete with configuration and ready to clear, I'm requesting your permission for the ULA Blue Team to exit the south roadblock along Titan 3 Road. I've been advised by my lead technician that that vehicle is low on fuel, and we will need to prevent going around the long way if possible.
And by south, you mean Titan Road?
Yes, sir.
Okay, just like we would when we did the original entry.
Yes, sir.
Yeah, copy that. And OSM, LC?
OSM.
Roger. Any concerns with the Blue Team, the ULA Blue Team, egressing via Titan Road back to the ASOC?
No, sir. I concur with that.
Roger. Copy that, Blue Team Lead?
I copy, and thank you.
Go ahead.
Station, this is Houston. Are you ready for the event?
I'm ready for the event.
ACR, this is Mission Control Houston. Please call station for a voice check.
Station, this is Houston ACR. How do you hear me?
I have you loud and clear. How me?
Loud and clear. Thank you. Please stand by for opening remarks.
Hello, I'm Kelly Poindexter, chair of the Link STEM Ready program and a chemical engineer. Today, we're connecting with astronauts at the International Space Station, including our Link sister astronaut, Jeanette F. Please welcome co-chair, Dr. Mamie Parker.
As a marine and wildlife biologist, I'm so thrilled to welcome you. Connecting with astronauts in space, how cool is that? Here is the first question.
Hi, my name is Armia Crutchfield. What is the most spectacular view you have seen in space?
Well, currently on the station, we have a window called the cupola, and you can look out that window anytime and you could see the Earth. And I thought that was the coolest thing that I had ever seen until we saw the eclipse from the space station. And what we saw from the space station was a shadow moving across the Earth's surface. And it was spectacular. So that has probably been the most spectacular thing I've seen since being here. But every day, looking out the window is a pretty amazing day.
My name is Jalen Travis.
Good afternoon. I'm NASA's Megan Cruz, and you are watching a press briefing following today's launch attempt of NASA's Boeing Crew Flight Test with NASA astronauts Butch Wilmore and Sonny Williams on a United Launch Alliance Atlas V rocket and Boeing Starliner spacecraft. Now, NASA, Boeing, and ULA were less than 4 minutes away from liftoff at 12:25 p.m. Eastern Time today, when teams had to forego the launch because of an automatic hold on the ground launch sequencer. So to talk more about that and what happened and what's next for this mission, we have here for you Steve Stich, Manager, NASA Commercial Crew Program. We also have Mark Nappy, Vice President and Program Manager, Commercial Crew Program, Boeing. And finally, Tori Bruno, President and CEO, United Launch Alliance. Now, you know the drill. Each will say a few words, and then we'll open up the floor and phone lines for questions. So, Steve, why don't you go ahead?
Yeah, thanks, Megan, and thanks to all of you for being here and your interest in our crewed flight test. We got really close today, and I would say the team did a phenomenal job, the joint NASA Boeing United Launch Alliance team working through the countdown today. The day started off, busy day for NASA at the International Space Station. We had a progress docking, 88 progress this morning at 6:43 a.m. Eastern time, so the progress docked nominally, and the station's doing well. At the same time as progress, of course, it's always busy. We got into the launch countdown today. Turned out the weather was a beautiful day to go launch. We were worried about the onshore winds, and those held within limits. They were right at about 14 knots, and so those would have been acceptable for launch today. We had a great chance to go look at the helium leak in the service module, what we call the P2D2 flange in manifold 3 in the port doghouse, manifold 2 in the port doghouse. And we looked at that leak today, and that leak looked like it was about half of what we saw before. So, we talked about it being on the order of 80 psi per minute in that manifold. Today, it looked like it was around 40 psi per minute. So that leak, that we think maybe the seal moved a little bit or the defect got sealed up a little bit. So that was good, and that would have been no issue for launch. So we went through our whole troubleshooting procedure, and that would have been just fine. I would say the launch vehicle did great. The Atlas and Centaur did great. The self-regulating valve that we talked about, and we're worried about a little bit going into the countdown, performed well. We didn't see any resonance at all, so that went really well. We did have a couple of items that we worked in the countdown, and Tori will talk more about those. We stopped in the topping phase on the Centaur. We had a little bit of a failure on the ground side, I would say, in the command and control system for those valves that are on the ground. And the ULA team did a magnificent job working through that. We got into a good configuration there. And then, right before we got into the final phase of the count, went off of ground power onto spacecraft power. We saw a little bit of a swap in the cabin fan, a little voltage sag. The ground team did a great job of troubleshooting that. We verified both fans were good, and we got those in a good config for launch. And then, of course, we got inside 4 minutes, and then we had a problem with the ground launch sequencer, and I know Tori will talk more about that. I know it's a little disappointing. We were all excited. Butch and Sonny were excited to go fly. This is kind of the way spaceflight is. This is my 37th year at NASA today, and been doing this human spaceflight for, thank you, a long time. And every time you go to the pad for a crewed flight, or really any flight, you've got a chance of scrubbing. So the team took the right steps. We weren't ready to go today, and Tori will talk more about that, and I'll turn it over to Mark Nappy now.
All right, well, thanks everybody for coming out this afternoon. The spacecraft and the launch team really did a great job today. The spacecraft performed extremely well. Steve talked about the helium system. It turned out that when the system was brought up, the team looked at the information really quickly, got us the leak rates, and ended up being no action required. So that's what we expected. On the cabin, on the suit fans, as we went from ground power to spacecraft power, a slight increase in voltage. We have a fault detection system that picked that up. It did what it was supposed to do, and it turned the fans off. Our team reacted just like they're supposed to very quickly, and they cycled them back on again. So that worked just as we would like it to. For tomorrow, or whenever we try our next launch attempt, we'll have that figured out, and we'll either let the same thing happen and see if there's the same voltage, or we'll just go in and turn them off and turn them back on again. So the team's working that, and we're fine for the next attempt. We're in a 24-hour scrub turnaround. We're trying to preserve that opportunity, and we'll stand by while ULA does their troubleshooting, and then we'll take either that opportunity or the next one to come. Like Steve said, this is the business that we're in. Everything's got to work perfectly, like we've talked before. Today we got really close. It didn't work for us. The team's very professional. They're in their 24-hour scrub turnaround right now, and when we're ready to go, they'll be ready to go. So I'll turn it over to Tori.
Thanks, Mark. Well, as Steve said, the vehicle performed beautifully, and we really had nothing to talk about on the vehicle itself. I also felt that the NASA, ULA, Boeing teams work really well together, which is important as well during a count. We had two events on the ground system. specifically that system that is housed inside the shelter at the base of the pad. So when you see the rocket roll out to the pad and the P-vans continue going into a building, it's in that building that we're talking about. And these events are associated with the controllers, the large computers that are housed in that building. There's 3 of them. They're the same, they're redundant, so it's triple redundant. The first event that we talked about had to do with the ground side topping valves. That one of those 3 racks was not commanding them to be open when we wanted them to be open. It is triple redundant, so we never had an issue with crew safety or with safety to the vehicle, but we worked through it and we switched the primary control to a different of the 3 racks, which is acceptable for that system. And so topping continued, and we never really deviated from that. As we get down to terminal count, then we do a health check of other systems, and one of the key systems there is a different card in the 3 racks that controls what is referred to as a launch sequencer. And that's a computer that controls things like retracting umbilicals and the pyro vents that release the bolts at the base of the rocket, so that when ignition happens, the rocket is free to fly away and do its job. And for that system, we do require all 3 systems to be running, triple redundancy. And to assure that, each of those 3 big racks, those 3 big computers, do a health check. And they monitor to see that those cards came up when they were commanded to come up and begin doing their job. 2 came up normally, the 3rd one came up, but it was slow to come up, and that tripped a red line that created an automatic hold, because although the health system did not note that it came up anomalously, it took longer, and so something is not correct. This is an instantaneous launch window for us because of the unique crew safety trajectory we fly. We're not able to use our famous RAN steering like we do when we take cargo to the space station. And so as a result of that late in the count, that ended up scrubbing the mission. What will happen next is to gain physical access to that computer and determine why that occurred. We can't get in there until we're done defueling the rocket, which is followed by making sure there's no stray hydrogen inside that building so that it's safe for people to be there. Then we'll go in and we'll troubleshoot it. So we are probably not less than, say, 3 or 4 hours from understanding what occurred. And if it's as simple as replacing a card, we have spares for everything. And we would do that. We would test it, which is required, and then be in a position to support a recycle for tomorrow. If it's more involved than that, or it just takes longer to get through all of that, then we would move to the backup day on the 5th. And as you know, we're set up for a backup on the range on the 6th as well. Weather for all 3 of those days look good, and so we'll know more, much later this evening.
Thanks, all 3 of you. Okay, so for those in the room, raise your hand, wait for a microphone to get to you, and then for those on the phone, you can get into the question queue by pressing *1. So Marcia, go ahead over here.
Marcia Dunn, Associated Press for Tori. It sounds like a hardware issue. Is that your best guess, or what's your leading suspects at this point with this 3rd computer?
Yeah, the leading suspect would be either a hardware problem or a problem with the network communication between these between the 3 computers and the system that interrogates them. But we won't really know until we get physical access and can troubleshoot that one rack that has this one card that came up slow.
Okay, over here, right behind Marcia.
Hey, thanks. Chris Davenport with the Washington Post. Tori, when you're talking about a card, I wonder if you get a little bit more information about what you're talking about in terms of that, if that's what that entails. Thanks.
Absolutely. So you should imagine a large rack that is a big computer where the functions of the computer as a controller, we call it a RIC, are broken up separately into individual cards or printed wire circuit boards with their logic devices. So they're all standalone, but together it's an integrated controller. which is what RIC is, integrated controller. And we do that to make it easier to troubleshoot them and to swap out parts so that you can replace just one element of it without having to replace the whole thing. It also helps in isolating which part of that control system is having a problem, if indeed it does. So you would imagine sort of 3 big racks side by side in this building with like 15 to 20 cards in them. I don't remember the exact count. And what we're going to do tonight is we're going to go in there and troubleshoot the cards. We'll likely have to remove several to evaluate everything, including the chassis, the power supplies, you know, the network communication between them, and isolate exactly why that happened.
Okay, we have one in the 3rd row there. Yes.
Mark Ratterman with Talking Space. A question for Tori. How many people will be hands-on looking at the equipment directly in front of it? How big is that team?
How many people will be in the shelter doing the physical troubleshooting tonight? I don't know off the top of my head. You know, probably half a dozen folks will be in there. There'll also be lots of people supporting them, both here and back in Denver. The design team will stay on and work through the evening with them to get to the bottom of it.
Okay, I see 3 in the room right now, then we'll go to the phones. Go ahead.
Jeff Faust, Space News. For Tori, is there a connection between the issue you saw with the topping valves earlier and then the issue then when you came out of the T-4 hold? Is it the same computer, the same card, something like that? Sure, Jeff.
It's different cards, but the same rack, or the same RIC, if you will, large computer. So they might not be related because they're, remember I said the cards are separated by function. But on the other hand, if it's something common in the comm system, you know, or the network within that rack, or its power supply, then it could be. I won't know until we get hands onto it tonight and then troubleshoot it.
The woman right here. Sorry, I should give you a break. You've been chasing people around.
Hi. Lauren Grush with Bloomberg. For Tori, you mentioned if it was a more involved scenario. Can you give us an example of what would be more involved other than just replacing a card that would push it back a few more days?
Yeah, they're an integrated rack of functional cards that have to communicate with one another and then communicate with the system. They're in a network, if you will. And so if there is an issue with that integration through the network, that would be more involved. If there were a problem with the power supply, it could be more involved, although we have spare parts for that too. We won't really know until we're in there tonight, hands-on.
Okay, we'll take Tom over here, and then we'll go to the phones and back into the room.
Hi, good afternoon. Tom Costello with NBC News. Thank you for this briefing. It sounds like you're more leaning towards hardware versus a software problem. Is that accurate? And second of all, if in fact you want, it's going to take 3 to 4 hours at this point, you said, before you gain access, and then you've got to try to figure out where the problem is within the rack, which card. Is it reasonable to think that you could still potentially move towards a noon launch tomorrow after you've completely, taken all the fuel off, then try to load again tomorrow? Or might you want more time to just absolutely be sure that you've nailed it all down?
Well, this is a crew mission, so we're going to be absolutely sure, period. Is it possible to be absolutely sure for tomorrow? Yes. If it's a simple matter as we examine the card that is the launch sequencer and find that it had a piece of hardware, a component, for example, that reached the end of its life, then it would be a simple matter of replacing it, and we would be able to support it. We have to put our crew back on console by 12:30 or so this evening. So that's sort of how long we have to do that. And again, if we can isolate it right away, we have spare parts here, we'd replace it and we'd go. Again, if it's more involved, then we would not be able to go.
At what time do you expect to make the call? Sorry, do you have an idea of when you make the call?
It'll be late tonight. It depends on what it is. If it's very obvious and it doesn't involve the systems that are utilized between 12:30 and, say, for example, heading into terminal count, we'd have more time. Obviously, we can't have people there when we're fueling the rocket.
Thank you. And if we're moving off the launch date, we'll get the word out tonight to you guys. I know you guys would like to know, and everybody would like to know. So if we're moving the launch date, we'll try to get word out tonight.
Absolutely. All right, let's go to the phones as promised. So we have Bill Harwood, CBS News.
Hey, thanks very much. This is also for Tori. We've been told that obviously you guys have to replace some batteries if you don't make it off the ground by, I guess, Thursday. Are those flight termination batteries? And I was just wondering, where are they located? Do you have to roll back to the VIF to do that if you have to? And how long would that add to the processing flow if you have to, in fact, change out the batteries before if you don't get off between now and then and you have to change out those batteries? Thanks.
Yeah, sure, Bill. So we're good through the backup day on the 6th. Beyond that, we have to evaluate it. And if we do have to change batteries, we will roll back. And it's about a 10-day cycle to go do that.
Okay, back here in the room. Over here.
Hi, Ken Kramer, Spaceflight Now. For Tori, what is the history of these cards and them having faults in them and having to be replaced over the course of the Atlas program?
Yeah, they've actually been very, very reliable. It's not unheard of to replace a card. You could imagine that all of these cards, that entire rack, all 3 redundant racks, were tested as part of the sequence leading up to the launch. They were all good. They all function nominally. They've all been used before.
So they've never failed?
No, I didn't say that. We've had card failures in the past. I don't personally recall whether this specific card has failed, but they're pretty reliable. We've been flying them a long time. We haven't had very many failures. I don't know that it's a card failure. Once again, I don't know what it is until we get people in there tonight and are able to examine it.
Thank you.
Let's go back to the phones. Micah Maidenberg, Wall Street Journal.
Thanks so much. I suppose it's for everybody. Could you just say a little bit more about, what it was like for the teams getting so close and then having it go the other way today? Thanks.
I can start off, and then we'll let Mark and Tori add. I mean, I think every countdown that I've been a part of, and many in my career, is a little different. I mean, this one, there's always things that have to get resolved in the count, and today it was certainly one of those kind of countdowns where the ULA team did a great job. When we couldn't get into stable replenish, when we had the failure, they did a great job working through that and getting to that point. It's always exciting to get the crew in the vehicle and watch that happen, and watch Sonny and Butch get on board, and then getting the hatch closed, and then the pressure checks, and then you get into the final phase of the count. And for me, I've been there too many times where you get a little excited. I think everybody's excited. Everybody wants to see the flight go, and then it doesn't happen. But then what really kicks in, and what I saw over in the control room and listen to the loops in Houston, is that everybody's very professional, and they're used to it. The ULA team moved right into what do they need to do to safe the vehicle and put the vehicle in a good config. Mark's team, the Starliner team, getting the abort switch off and making sure that we had that in a good config for the crew, making sure the vehicle was safe, going through all those steps. And so there's disappointment. It's human to be a little disappointed, but then you watch the team kind of get into action, safe the vehicle, and then you listen to the loops, and they're talking about what potential the potential cause could be, and that's what Tori's team is doing right now, is going to go and look at the rack and get their hands on the system and look at the data from today. Is there anything they can glean from the data? So it's disappointing. Everybody's a little disappointed, but you kind of roll your sleeves up and get right back to work, and I'll see what Mark has to add.
I would agree with Steve. I'd kind of use the analogy of sports. When you're playing a game and you get a bad call, you're a little irritated at first or a little frustrated at first, but you immediately focus on the next pitch. And that's what our teams do. They're focused on the next pitch. As soon as we went into the launch scrub, the launch turnaround, I looked out into the control room, and everybody had their heads down, working the procedures to get ready for another attempt tomorrow. The technical guys were looking at all the things, all the data that they had so far, and they're scanning the data to make sure that nothing else was out there for us to go work. So the team's professional. They just work to the next play. Tori?
Yeah, I mean, you guys have said it. The disappointment lasts for about 3 seconds, and we've been at this a long time, and then you just immediately get busy and do your job. And we'll be back.
Joey? And then we'll bounce back to the phones. We have a couple on the phones as well.
Thanks. Quick one for Tori. Is it, just so I'm clear, is it accurate to call the 3 cards separate computers, or is it all part of a single computer?
3 big computers. Each one has several cards in it. And the reason it has several cards is because we separate the functions that you would observe being done through the count. So there was a card that controlled topping valves and other systems similar to that. This card controlled the launch sequence, which is removing all the things that are trying to hold the rocket on the ground before the rocket ignites. And this was that card within this big computer that had all those functions separated into different cards. There's 3 of those computers. They're redundant. Some of those systems majority vote. Some of them just require 1 to work. This one requires all 3 to work before entering terminal count, so that we are guaranteed statistically of having not less than 1 of them properly functioning at the moment of ignition.
For Steve, real quick, if it launches tomorrow, what docking time would that be on Monday?
Of course, tomorrow, the launch time, if we go tomorrow and we've got to get through the troubleshooting, would be Sunday, June 2nd, 12:03 Eastern. And it's about a 24-hour rendezvous. So the rendezvous is Monday, June 3rd at about 1:05 Eastern or so.
Okay. Back to the phones. As promised, Stephen Clark, Ars Technica.
Thank you, Stephen Clark, Ars Technica. Just a question for Tori. I know you guys did not do a web rehearsal for this particular launch. If you had done a rehearsal, was there a chance this rack card issue could have been discovered as you came into the final limits of the accounts?
Possible, but unlikely. This system was tested during the run-up to this launch, and it passed those tests and functioned completely nominally. So it chose not to do that today. If there had been a WDR, I don't know whether it would have chosen to work that day or not.
And I would just say from my shuttle experience, every now and then we would have some failure at some system at the pad. The pad, we always think about Starliner being super complicated, and it is a very complicated spacecraft, wonderful spacecraft. The launch vehicle, both the booster and the Centaur are complicated, but the ground systems are equally complicated. I think sometimes we forget that, right? They all have to work together to launch, and I would say in shuttle, many times we would have a ground system failure that would cause a scrub, and that's what we had today. So.
Okay, back here in the room. If we can get a microphone to, thank you.
Sawyer Rosenstein, NSF. After the topping off change that was done, it sounded like there was a release of 1,000 psi of helium. I was wondering if you can kind of talk about what happened and if you know the cause of that particular release.
Sure. So part of the sequence of moving that functionality to the other 2 cards and not using that first card in the rack did also vent the helium bottles, which we then had to recharge. It's a routine operation. I will say the only thing painful about that is the price of helium went up almost 10 times over the last 2 years, so we wince whenever we vent helium. But apart from that, it was a routine thing, and we simply recharged the bottles.
All right, back to the phones. Irene Klotz, Aviation Week.
Thanks, Megan. Tori, would the 3 controllers be required if this was not a crewed launch? And in general, how much tighter would you say the launch commit requirements are for flying Atlas V with crew versus like your national security payloads?
Yes, Irene, we work very hard to have high mission reliability on every mission because they're all critical. The difference between this and a satellite mission that didn't have people on it, a satellite still requires all 3 redundancy to enter terminal count. However, we would have 2 things would have been different. One, we almost never have an instantaneous launch window when we are not launching people. This is a very unique and special trajectory that protects the safety of the crew by allowing them to have a free Earth surface routine all the way through Atlas's powered flight. And we're not able to do the things that create these big launch windows that we're more known for. So we would have had more time to look at the event. And during that time, knowing that there was no crew present, we may have arrived at a conclusion that it was worth proceeding with dual redundancy versus triple. It depends on what we were able to assess during that time. I don't know, because that's not this circumstance. But with crew present, that was an unacceptable condition. And we were not going to make that decision in a few seconds, which is really all we had.
Okay, in the front row here.
Thank you. Faith Abube with ABC News, and this is to all of you. Considering this mission is now years behind schedule and with all the setbacks it's had, what do you tell anyone out there who's losing faith in this mission?
Yeah, I'll start and then we'll see if Mark has anything to add. You know, we are really excited about bringing Starliner on board the Commercial Crew Program and the International Space Station Program. We really would like to have and need 2 redundant space transportation systems. And, you know, it's really important to us to have that. And, you know, you could see today how close we are. We are really close to having this capability ready to go launch. We were 3 minutes and 56 seconds away from that with a Starliner spacecraft that was ready to go and an Atlas launch vehicle and Centaur upper stage that was ready to go. So the vehicles were ready. We just happened to have, you know, an unlucky ground card problem. So we're really close to being ready to fly this mission and then go through our certification. And we're excited to go embark upon that, and we'll fly when we're ready, and it should be soon. So.
All right, on the phone, David Curley, Full Throttle.
Question for Tori. Have you ever had this happen before? You've had a lot of launches of this rocket. And if not, why do you think it is this one potential computer? Did you actually see signs that it was booting up slowly or responding slowly?
No, we didn't see any anomalous behavior with this card. The first indication of this event, again, was at the sequence just prior to T0, or I should say to terminal count T-4 that allows us to enter that, is powering up. As I said, 2 came up nominally right away. The third one was about 6 seconds slow. That it came up and it was functioning, but that in itself was an indication that something wasn't correct, and that's why the automated system tripped on that. We have seen card failures in the past. I don't recall if we've seen this one fail in the past. They are relatively rare. This is the 100th flight of Atlas, so we haven't had more than a handful of these over the years. So it's not a common occurrence, but neither is it something that's unheard of.
Okay, back here in the room. We'll go here. You've been raising your hand, yes, and then
All right. Thanks, Richard Tribou, Orlando Sentinel. This question is for Steve. How deep into the summer can this mission push without running up on the other ISS traffic? And what is the timeline for certification after landing? And just confirming that SpaceX and Boeing would both be training toward a potential February 2025 launch, depending. That's it. Thank you.
Yeah, relative to the International Space Station and the traffic, we, as we've talked about, we sort of set up this summer, May, June, July, to really have that window open at the space station. So the next big set of events at Space Station really has to do with our handover, our crewed handover coming up, and that's in mid-August, right? We'll have Crew 8 to Crew 9 in mid-August. The second part of the question was relative to certification. We'll have to work with Mark after the flight. You know, we had it laid out when we were in early May. You know, it's a number of months. We're trying to get to a certification review toward the end of the year, and then we'll just have to look at the data that comes out of the flight. We know, Mark talked about it really well yesterday, a number of products that we have to have lined up, and we know what those are. We've started reviewing those, and NASA's approved many of those already. We're also setting up for having the ability to dock at the forward port on the International Space Station, also the Zenith port. So that software is in work, and all the analysis with the space station program's in work. So we have all that underway. And then, yeah, we are protecting in the February timeframe next year, both Starliner 1 and the SpaceX flight as well at the same time.
Okay, go ahead.
Hi, thank you. Marissa Parra with NBC News here. This is sort of a follow-up to Tom's question regarding the timeline. Say you get out there, you make the judgment call that this can be fixed, you make the judgment call later tonight, you're going to work through the night, I'm assuming, to do exactly that. Say you were working through the night, through the morning even, when would be the deadline that you say, we simply cannot continue working on this because we're getting too close to the launch? Is it all the way up until launch time, or is it earlier than that?
It's earlier than that because, you know, the rack we're talking about is adjacent to the rocket in that shelter I described earlier, which means that when we begin loading the propellants into Centaur and the LOX into Atlas, that we can't have people there. Because of safety concerns. And so it's at that point that if we don't think we can get it done before then we would not be able to finish.
Okay, and Will back here.
Thanks. Hi, Will Robinson Smith with Spaceflight Now. Thanks again for taking the time to speak with us this afternoon. Question for Mark. Besides the issue with the fans that came up later on in the count, was there anything else out of character with Starliner, or can you talk about how it performed during the countdown process today, and if you learned anything about getting to this point in the count? Thanks.
No, the vehicle performed exceptionally well. We had no other issues that we worked throughout the count. So we'll review data over the next 24 hours to make sure that everything performed as we saw it, but there was nothing there.
All right. Final call out for questions here in the room or on the phone.
I think Mark had a response to my question.
I only care about what my customer thinks, and you heard what my customer had to say. So
I'll pipe in. The nation needs 2 ways to get to space, at least. We're at the finish line. Let's take one more step.
Tom.
Understanding that this stuff happens, how much does it cost? This kind of assuming it's a 24-hour delay, how much does this cost, and who picks up the cost? In other words, you've got all of your technicians, your engineers, your whoever is on working and has to work again, and the fuel costs. I'm just wondering if there's a cost estimate for that.
I think we'll have to get back with you on that. To be a rough estimate that we would make on how much it costs for a 24-hour turnaround.
All right, Ken.
Ken Kramer, Spaceflight Now for Tori. I think you mentioned, if I understood you right, you can't do RAN steering on here, or you might have a wider launch window. So I was just curious why you can't do that, please. Thanks.
Yeah, so 2 reasons, and they're both kind of the same answer. It's about energy. For those of you who are not familiar with right ascension of the ascending node steering, apologies for the rocket science term, it means that you're able to launch before or after the perfect time. And there's always a perfect time because it's a rendezvous. The pad is moving at 900 miles per hour. You're all moving at 900 miles per hour right now. And the space station's going more like 17,500. And so it's an intercept. And so when those orbital planes go up, that's the ideal time, and it takes the least amount of energy to do that. Because we're flying the trajectory we are, uniquely associated with crew safety, something, by the way, we've never done before the prior Starliner missions. It's suborbital. We're used to going to orbit. But this allows us to fly low and flat with a lot more thrust. That's why there's 2 RL-10 engines on the upper stage instead of 1, so that we've never had what NASA would refer to as a blackout period where it would not be safe to separate, God forbid, in an abort and have the crew safely return to the Earth. And in fact, when we get done, we haven't given the Starliner enough energy to get all the way into orbit and go to the space station. It then lifts itself. So between the amount of energy it takes us to do that and the energy limits that are on the Starliner to be able to be dropped off somewhere to do that, we're not able to do RAN steering, where we would launch either before or after the ideal time, because that also takes energy as well as some sophisticated guidance algorithms. So this is like everybody else who goes to the space station. We're used to having that 25, 30, 35-minute launch window when we take cargo, because we don't have to do that for cargo. But we don't have that luxury here, and it's about safety.
It's really about the ascent aborts, right? We NASA wanted a very robust abort system should something happen to the rocket. And so, you know, what Tori talked about is the trajectory has been optimized, how the Atlas flies, so that at any point, if the Atlas has a problem, Starliner can separate, fire its engines, whether it be the launch abort engines or the OMAX, separate, and then not pull too many Gs and have a safe entry and land in the water, and we'll go recover them. So it really is about crew safety, as Tori said.
Hey everyone, thank you for your questions. We really appreciate your interest in this mission. Before we wrap up, we do want to go over the launch attempts on the 5th and 6th, if you want to do that.
Yeah, I will provide the two different launch times for June 5th and June 6th, should we get into those. Of course, June 5th is 10:52 Eastern. And again, the rendezvous is about a 24-hour rendezvous, so you rendezvous approximately 24 hours later on June 6th. And then the June 6th launch time is 10:29 a.m. Eastern. Again, rendezvousing about 24 hours later on June 7th. So thank you very much.
And for those interested in the launch broadcast, we always start around 4 hours before launch so we can capture the crew going in for suit up. All right, again, thank you so much again for your questions. And as you heard our folks here on the dais say, we should know a little bit more in a few hours, 3 or 4 hours or so. So we hope you keep in touch with us and check out our updates on our blog. So we'll pull that up now for you. It's on the screen, blogs.nasa.gov/Boeing Crew Flight Test. We have a lot of blogs. I almost read the wrong one, but it's that one on the screen, blogs.nasa.gov/Boeing Crew Flight Test. Again, stay tuned, please, and thank you for your interest, and have a great afternoon. you.